Good evening, one and all. I am here to explain Shannon Fanon coding in digital communications, 5th semester ECE. There are two types of coding techniques, which is known as which we can know popularly as Shannon Fanon coding and Huffman coding. Now we are here to know about Shannon Fanon coding. In Shannon Fanon coding, there are four steps in the Shannon Fanon coding procedure. The first step is known as sort the list of symbols in decreasing order of the probability. In the question, we can get some probabilities of values with random numbers. Now we have to assign that probabilities in the decreasing order from top to bottom. And in procedure step 2, partition the set into two sets that are close to equiprobable as possible and assign 0 to the upper set and assign 1 to the lower set. Now we have to, after placing the probabilities in the decreasing order, we have to divide that probabilities into half and we have to check the equiprobable with less difference. Where if in this we know that we are dividing 0.4 and 0.2 as one set and 0.2, 0.1, 0.1 as one set. By adding 0.4 and 0.2, we can get 0.6 as the sum and 0.4 as the sum for set 2. So that we are having a less difference between those two numbers. So we are taking that upper one as upper set and lower one as lower set. So that we are assigning upper set with zeros and lower set with ones. In procedure number 3, we have to do the steps for all the individual until all the individual subgroups are formed. Now we are seeing that in stage 2 we are splitting that stage 1 0 to 0 1 and the lower frequency, the lower set in the stage 1 is splitted into two with equal equiprobability of 0.2 and 0.2 and assigning 0 as the upper set and ones for the lower set. In stage 3 we are splitting that equiprobability of we are getting equiprobability for the stage 2 with lower set and we are assigning as 0 1. In fourth step of the procedure we are assigning the code word as the binary values which is obtained in the each stages. Now we can take a problem that a discrete memoryless source has a symbols of x1, x2, x3 and x4 with probabilities of 0.4, 0.2, 0.1, 0.2 and 0.1 respectively. We have to construct a Shannon-Fanon code for the source and calculate the code efficiency neta. By using Shannon-Fanon coding procedure, we can form a table which we can see on the screen. We are assigning the probabilities in the decreasing order and the sum of the probabilities is equal to 1, which we know the formula is very well known formula. By adding all these probabilities, we can get their sum as 1. Now in stage 1, we are splitting that all the probabilities into two halves with the less difference between them. And we are splitting 0.4 and 0.2 as one set and 0.2, 0.1, 0.1 as another set. We are assigning the upper set with zeros and the lower set with ones. In stage 2, we are assigning 0 1 for the upper set, which is having 0 0 in stage 1, and we are splitting that lower set into upper set and lower set again and assigning 0 for upper set and 1 for lower set. Now here we are having 0.2, 0.1, 0. We can split that equally with 0.2 and 0.2. We are having 0.2 in the upper set and 0.2 in the lower set. So that we are assigning 0.1, 0.0 in the upper set and 1s in the lower set. For stage 3, we are dividing that lower set of stage 2 into equi probabilities. We are having 0.1, 0.1. We are dividing that with equi probabilities known as we can get the 0 for the upper set and 1 for the lower set, so that we can get the individual tables for all the probabilities. Now we are getting to the code word. In code word, we are taking all the stages values in the code word. For 0.4, we are getting the values of 0, 0, binary values of 0, 0 in the code word. For 0.2 with symbol x2, we are getting 0.1 in the code word. For 0.4, 0.2 with symbol x4 having the code word of 10. For 0.1 with symbol x3 having the code word of 110. For 0.1 with symbol x5 having the code word of 111. Now we are taking the number of bits per message ik as the code word size. We are having 2 bits in the 0.4, 2-bit code word in the probability of 0.4 with symbol x1. So we are assigning 2 for the 0.4. And similarly for 0.2 also we are assigning 2 because we are having the code word of 01 with 2 bits. For 0.2 with symbol x4 also we are assigning 2 similar to the previous one. For the probability 0.1 with symbol x3 we are having the code word of 0110 having 3 binary bits, so that we are having the message number of message bits is 3. And for similarly for x5 symbol x5 of probability 0.1 having the same message bits 3. So here we are going to find the average code word length. The formula for average code word length is L bar equal to sigma k equal to 1 to k pk into ik. Pk is known as probability, ik is known as number of bits per message. We are multiplying that both values with summing of all the values, so that we can get L bar equal to 2.2 bits per symbol. Bits per symbol is known as the units of the message, units of the word. To find entropy, we are using the formula of h of x equal to sigma k equal to 1 to k pk log 2 1 by pk. Here pk is known as probability, so that by using that table we are substituting that probability values in the entropy formula by adding all the probabilities, so that we can get h of x equal to 2.12192 bits per symbol. To find code efficiency, neta, which is the h of x by L bar, which is known as efficiency efficiency equal to entropy by average code word length. We are getting efficiency of entropy of 2.12192 and average code word length L bar equal to 2.2. By dividing both the values, we can get the efficiency of neta equal to 0.9645. By getting that neta percentage, we have to multiply with 100, so that neta percentage equal to 96 percentage. In the fourth, to find code redundancy, the formula is gamma equal to 1 minus neta. We are finding that neta in the previous step as efficiency. We are getting 0.9645 as the value of neta, so that 1 minus 0.9645 which gives 0.0355 as the code redundancy for this problem. Thank you.